Hi, welcome to lesson 3 of vectors. Today we're going to be looking at multiplying vectors. So just a couple of things we need to remember from previous vector lessons. That a resultant vector is the vector you get when you add or subtract vectors or their multiples. For example, we said a vector A plus a vector B, or you could have vector B subtract vector A, or something like 2A add 3B. And that's the type of vectors we're going to look at today. The other thing was negative vectors. So if we just remember that a negative vector is just the same size but in the opposite direction. And all we do is we swap the signs of the column vector to get the negative vector. So here we have a vector B, which is from start to finish 4 to the right and 2 down. So the column vector is 4 minus 2. So that would mean the column vector for negative B would be negative 4, positive 2. So think from start to finish, we need to go 4 to the left and 2 up. Okay, let's look at multiplying vectors then. So here we've been given two column vectors. A vector P is represented by the column vector 2, 3, and the vector Q is represented by the column vector negative 1, 1. And we have been asked to find the column vectors for 2P. So it's just like your algebra. 2P means 2 times P. So here we multiply the column vector 2, 3 by 2. So at the top we do 2 times 2, which is 4, and at the bottom we do 2 times 3, which is 6. So the column vector for 2P is the column vector for 6. If we look at the next example, we have the vector 3Q. So similar idea again, we multiply the vector Q minus 1, 1 by 3. So we multiply the number at the top and the number at the bottom by 3. And that gives us the column vector minus 3, 3. The third example we have here is negative 5p. So this time we're multiplying by negative 5, and we just need to remember when we're multiplying by a negative, or in this case we're getting a negative vector, so we need to swap the signs. So we multiply 2, 3 by negative 5. So we do negative 5 times 2, which is negative 10, and negative 5 times 3 is negative 15. So nice and straightforward. Then we can combine vectors as well, so we can add or subtract the multiples. So the fourth example we have here is P add 3Q. So the vector P is 2, 3, and we're going to add that to 3 times the vector Q. So we're going to add that to negative 3, 3. Now we've already done adding and subtracting vectors. We know we just total the top number and total the bottom. So 2 add negative 3 is negative 1. 3 add 3 is 6. So the resultant vector, the resultant column vector for P add 3Q is negative 1, 6. The last example we have here is if we want to get the resultant vector for 2Q minus 3P. So that would be double of Q, which is minus 2, 2, subtract 3 times P, which is 6, 9. So looking at the x components at the top, we've got minus 2 subtract 6, that gives us negative 8, and then 2 subtract 9 is negative 7. So the resultant column vector for 2Q minus 3P is negative 8, negative 7. Okay, let's see how much you understood from the previous slide. So here we've got 6 examples. If you pause the video and have a go at these yourselves, and then come back in a minute or two and check to see how you got on. Okay, let's have a look at the first example. So we have 2p. So we are going to multiply the vector 2, 3 by 2. So 2 times 2 is 4 and 2 times 3 is 6. So we end up with the resultant vector 4, 6. For the second example, we have negative q. So we are going to multiply the vector minus 1, 1 by negative 1 technically. So we're just basically swapping the signs. So this vector becomes +1, -1. For C, we have a half p, so we are just multiplying a half times 2 and a half times 3. A half times 2 is 1. A half of 3 is 3 over 2, so we would write that as 3 over 2 rather than the fraction. Or sorry, as a fraction rather than a decimal. Example D is p plus q, so we're just going to add together 2, 3 and -1, 1. Adding the x components together, 2 add -1, we end up with 1, and then 3 add 1 is 4. For example E, we have 2, 3, subtract -1, 1. So we need to watch out for double negatives here. So in our x components, 2 subtract -1, remember double negative is a positive, so that's 2 add 1, which gives us 3 as our x component, and then 3 subtract 1 for our y components at the bottom, which gives us a 2. So our resultant vector for p minus q is 3, 2. The last example then, we have 3p add 5q, so we need to times p by 3. So 3 times p is 6, 9, and we need to multiply q by 5. So we have -5, 5, and then work out what our total is here. So our resultant vector is 6, take away 5, which is 1 at the top, and 9 add 5, which is 14 at the bottom. So we have a resultant vector of 1, 14. Here we've been given an example where we're asked to draw diagrams to represent the vectors 2u, 3v and -3u. State the components of each vector and calculate the magnitude of each vector. Previously we were given column vectors to use, but in this example we've been given diagrams of the directed line segments. So all we have to do here is just identify the column vector first. If we look at A, vector v, from start to finish we need to go 3 to the right and 1 up, so therefore it has a component vector of 3, 1. But we've been asked to find vector or draw vector 2u, so we need to double the components. So it's 2 times 3, 1, so that's going to give us 6, 2. So from our starting point we go 6 to the right and 2 up, draw in our vector and label it with the arrow in the right direction, and that gives us our diagram of 2u. To calculate the magnitude, we should be doing this in our sleep by now. We know we just do Pythagoras with the x and y component values. So the magnitude of 2u, remember the symbol has the vertical lines either side, is the square root of 6 squared plus 2 squared. So we work through that and get the square root of 40, which is 2 root 10 or 6.32 units. Let's look at example B. Here we have the vector v. From start to finish we need to go 2 to the right and 2 down, so it has a column vector of 2 minus 2. But we've been asked to draw vector 3v, so we need to multiply these components by 3. So 3v is 3 times 2 minus 2, which is 6 minus 6. So from our starting point we need to go 6 to the right and 6 down, and we draw our vector in and label it with the arrow in the correct direction. Once we've done our diagram, we've been asked to calculate the magnitude again. So exactly the same, the magnitude of 3v is the square root of 6 squared plus -6 squared. So we work through that and we will get the square root of 72, which simplifies to 6 root 2 or 8.49 units. Third and last example, we'll just need to go into another slide for that. Here we have the last example, and it's based on vector u again, and we already said that the vector u was the vector 3, 1. But we've been asked to draw the vector -3u. So we need to multiply the components by -3, so that will give us -9, -3. Remember, the -9 tells us we're going 9 to the left, and the -3 tells us we're going 3 down. So from our starting point we go 9 left, 3 down, and that will give us our vector -3, 3u, making sure we label the vector and the arrow is pointing in the right direction. The last thing we've been asked to do was calculate the magnitude again. So one last time, the magnitude of negative 3u is the square root of negative 9 squared plus negative 3 squared. Working through that, remember when you square negatives you always get positives, so we end up with the square root of 90, and that simplifies to 3 root 10 or 9.49 units. Okay, now it's over to you, time for you to have a bit of practice on multiplying vectors. So all I want you to do is have a go at questions 1, 2 and 3 on Vectors Worksheet Exercise 3. Remember to mark your work and do any corrections. The answers are at the end of the worksheet. Once you've done that, that's your lesson done for today. If you do have any work left from previous lessons, whether that's vectors or revision, and you've still got time, you could always have a go at them. Thanks.